let's get started. So what we're having a look at now, exponential equations. Exponential equations. So we're going to use the rules that we learned previously to solve some problems where the x is in the power. So really for this lesson we're just looking at lots of examples of using the rules that we learned. So the first example we'll do is 64 power x plus 2 equals 4 squared. Anybody have any ideas on what to do here? We should do something with the 64, shouldn't we? Yeah, what should we change it to? 8 squared, or maybe 4 power 3? 4 power 3 x plus 2 equals 4 squared. So that's 4 power 3x plus 6, using whichever rule it was, rule 3, equals 4 squared. That's it, yeah. So it must be that 3x plus 6 equals 2. So that means 3x is minus 4, isn't it? So x is minus 4 over 3. Okay. Right, that's our first example. You can write that down. You got that? Yeah. Okay, can we scroll down? Yep. Yeah. Right, next example now. Two power x plus 7 minus 7 root 128 power 9. That's equal to 0. Okay, what do you think I should be doing first here? Yeah, yeah. Like that. Yeah? And then next? Yeah, put the fraction in for the root part. So 2 power x plus 7 equals 128 power 9 over 7. Okay, next.
128 can be changed into 2 to the power of 7.
2 7, is it?
It becomes 2 9.
Yeah, they cancel. Yeah.
So x plus 7 equals 9.
Okay, that's our second example. We got that?
No.
Not yet? Okay. Yeah? Yeah, okay. Next example. Again, trickier now. 9 power x minus 12 times 3 power x plus 27 equals 0. What should I do first here for this one? Who knows? 3 squared, yeah. I should change the 9 to 3 squared.
And 27 plus.
No, actually, not necessary, yeah.
3x equals to
Yeah,
8, and then
we'll do that bit in a second. I'll just change this to 3x squared, yeah.
That'd be 3x's equal.
Yeah, you can all see what type this is. What is it? It's a quadratic. Except, instead of x, it's 3 power x. Yeah? I'll just go straight into factorizing it. Yeah, we don't need to do the substitution. It's obvious it's a quadratic with 3x here and here instead of x. 9 and 3? Yeah? Like this? Yeah. Question? Yeah? Yeah? Why did I? 2. Oh! Do you mean from here to here? I didn't have to. I just wanted to make it clear that it was a quadratic, that it's kind of like me saying we have x squared minus 12x. I just wanted to make it clearer that it's a quadratic. I could have kept it like that. It's no big deal. Alright. 9 is 3 squared. And 3, of course, is 3 power 1. So we finish off by saying x must be 2 or 1. Yeah.
And now we should check for.
Not for these. Not for this one. I mean, it's good to check, but it should always work here for this one, for these types. Okay, can you write that down? Yeah. No, sorry, a little too late. You can come back for the second class. Yeah, just a little bit too late. Come back at 10 to 10, okay? Okay. Did you write that down? Not yet? Okay. A lot of people suggested making a substitution, which is fine if you want to do that in the exam. But for me, I feel it's an unnecessary extra step because it's quite clear that it's a quadratic here. You know? But, I mean, if you want to use a substitution, that's fine. No problem. I think the danger of using a substitution is this could happen. You know, you would say u squared minus 12u plus 27 equals 0, yeah? And then you would say u minus 9, u minus 3 equals 0, yeah? and then you would say u equals 9 or 3, and then you would stop, forgetting what you're doing, you know, realizing you haven't actually found x yet. I've seen this happen. So if you do use a substitution, make sure you don't forget what you're looking for, which is x. Okay, can I scroll down? Right. Minus 8x minus 9 over 5 equals minus 3x power 7 over 6. Okay, what are we thinking about here that we could do?
Get rid of the minus.
Well, yeah, we should definitely get rid of the minus first. Okay. And what about now? Not necessary, not necessary. I think what I'll do is I'll divide by the 3, and I'll divide by the x power minus 9 over 5. Right? You're just going to leave that hanging there? Yes?
How and why?
Why?
I brought the 3 down to the left, and this x down to the right. Now the reason I'm doing that is just to get the x's on one side.
Oh.
So now on the right I'll have x power 7 over 6 minus 9 over 5. So that means 8 over 3 will equal x. This will probably be a 30. And that'll be 45 minus 54. Is that minus 9 over 30 minus 3 over 10? 3 tenths, is it? 3 over 10?
89 over 50. 7 over 6 plus 9 over 5.
What is it?
89 over 30.
Yeah.
Because there's a minus one.
Minus 1 is plus.
Okay. 89 over 30. Oh, I minus them. Yeah. Right, so there's only one step left to finish this. Can anybody see what that step is?
Log.
No, we'll try and avoid using logs. So, yeah?
Like you move it over 9, it's to the other side.
How? By doing what?
Squaring it by 20 and
Right idea, wrong words, but I know what you're saying, yeah. It's not squaring, I know what you mean, raising it to a power. So what power do I raise it to? 30 over 89. Now what's so great about that? They cancel there. So you're left with x equals 8 over 3 power 30 over 89. That's the exact answer. Okay, so now you see that's a bit tricky. Write that one down, please. Okay? Yeah? Can I scroll down? Not yet. Yeah? Next now. Oops. So, this question, it has two parts. The first part is I want to know the range, and the second part is I want to know where they meet, where they intersect. And by range, I mean the range for y. What are the possible values for y? Okay, so the first part here, when you look at this formula, what is the smallest value you could possibly get for y? 1 or 4, yeah, which is it? It's 1. For what value of x? No. Because if it was 0, you get 4. No. So, if x is some number like minus infinity, if it's very small and very negative, like minus a million, then this piece here will be roughly 0. And if you think about the graphs we did yesterday, remember the graph? It looks like this. So, out far to the left here, it's very small. Yeah? Are we okay with that? Do I ever actually get 1? Or is it only something I can approach? It's only something I can approach. Yeah. So, strictly speaking, I don't include the 1. It's open here. Now, what's the biggest that this could be?
Plus infinity.
Plus infinity, yeah. And of course, I can never actually get that for any value of x. Okay. Now, this second one is a little bit trickier. So, again, what is the smallest value I can get? Yeah.
You can be minus.
I think I could get minus infinity.
Yeah.
Okay, because look what you can do here. You can say this is,
If x will be plus infinity, you can do
that would be, if x is plus infinity, we get 7. But look what I can do to this. So I change this to 7 minus 2e. Well, actually, I could just leave it the way it is. What happens if the ex is very small? What happens to this fraction? It's bigger, isn't it? Yeah? Yeah. And 7 minus a large number? Minus a negative. Be a number to the left on the number line. Is it possible to make e power x very small? It is, actually, by just making x very negative. You know, so for example, if I have x is minus 1000, then e power x would be very small. 2 over a very small number is a very large number. 7 minus a very large number is a very negative number. So I can see this going all the way to minus infinity. Now, the next question is, how big can I make it? So let's just think about this logically. If I want to make this really big, then I have two choices. Or really, I have one choice. I want to make this a positive, but I can't do that, so it's not really a choice, because e is always positive, and because the minus in front, then it's always negative. So I can never make this positive, which is unfortunate. Second thing I could do is, well, if I want to make this very big, I could take away a very small amount. So what's the smallest I could take away?
0.
I could possibly take away 0, but I would need to make this ex, yes, exactly, very large, yeah. So if I make this very large, by maybe using x as 1000, then it's 2 over a large number, which is very small. 7 minus a small number is nearly 7. So again, I don't quite think I can get the 7.
So it will be open.
Open again, yeah? Now, they don't ask this question on the exam much. I mean, maybe they've asked it twice, you know. But it's a skill that you may need for the exam, where they give you a formula with e in it, and they might ask you a question like, what is the biggest value this could be? What's the smallest value this could be? And you just have to look at it like how we just did, and just think logically, how big could I possibly make this? And how big could I, or how small could I make it? Okay. Usually the question comes up in a practical problem. You know, the y might represent some process, something happening, whatever it is, and the x might represent time, you know, something like that. And the question might be, what is the biggest value you can get in this process? And you have to look at this and go, well, okay, if the time is really big, then this would be nearly 0, so I guess the most it could be is 7. You know, like the last question where I saw this, it was something like you had a formula for room temperature. So the y was like temperature in the room, and x was the time that passed. And the question was, what's the final temperature in the room? What temperature is the room approaching? And in this case, if it was a formula like this, it'd be 7. So it's a skill you might need. And the last thing you might need for the exam, again, it's not super common, but it does come up once or twice, is where do these two graphs meet? Because if you picture the graphs, if I just scroll and draw a rough sketch, this one here is going like this, and what's this one doing? Oh, I don't know, it's whatever, it's going like that. They'll meet, and we want to find out where they meet. So,
Do you know that it's like 2 points where they intersect?
I don't really know. I just drew 2 curves, and I'm hoping for the best. But I'll find out now. In fact, maybe they don't even meet, but we'll find out now. So, what should I do here? Yeah, but which method?
Substitution.
Yeah, substitution, because they're both equal to y, aren't they? Right? Okay, this isn't exactly easy. What should we do now? Well, at least I can put the 1 and the 7 together, so maybe I'll do that. So that's 3ex 1 minus 7, or minus 6, and then plus 2 over ex equals 0. Now, I wrote it like this to give you a little hint on what to do next. Multiply, yeah, by... Very good, by e power x. So, this would be 3ex times ex is ex squared. And this is 6 times ex. And then 2 over ex times ex? 2. Oh, and what can I divide by here?
2.
I can divide by 2. Oh, no, I can't.
No, you
Oh, rats, okay. What type is this? This is quadratic?
Yeah, it is.
Yeah.
Correct.
Maybe it has roots. Does it? No, actually, I don't think it does. It's going to be a minus b formula, isn't it? Don't think this has factors, right? We can no factors. Okay, so you get ex equals minus b plus or minus square root b squared minus 4ac all over 2a. So is that 6 plus or minus root 12 over 6? Is that right? Yeah. I can simplify this because this I can divide by 2, can't I? 3 plus or minus root 3 over 2 over 3. Is that what you got in the calculator? Yeah. So we have 2 answers here. Either e power x equals 6 plus root 12 over 6, or, 3 plus root 3 over 3, or 3 minus root 3 over 3. Now, you know how to answer this, because think about the question we're posing. We're saying e to what power will equal 3 plus root 3 over 3. And here we're saying e to what power equals 3 minus root 3 over 3. Where have we seen that before? Yesterday. Right, it's the definition of log. Log is for answering these questions, isn't it? Log tells you what power to use. So this would be log what base? E. 3 plus root 3 over 3. However, on your calculator, how is log E stored? Oh, mistake? Yeah. Ah, square root 12 is square root 4 times 3, which is 2 root 3.
Oh,
And then I divided everything by 2.
that's why.
Oh, you could have said something sooner. It's okay.
Yeah.
Alright. I'm sorry, I thought, okay. It's okay now, yes? Yeah, okay. So how do we store log base C on the calculator? ln, isn't it? So here the answer is ln of 3 plus root 3 over 3, or it's equal to ln 3 minus. Oops. Now, it depends on what the question says. If the question's asked for the exact answer, then you would actually stop here. But if it didn't say the exact answer and you wanted to give a decimal answer, you could. 3 significant figures. So x equals, or, so what are the 2 answers here? 3 SF, please. Or what's that? Say again, Ishpreet, the first one? Yeah, what's after the 6? Did you round up or down? Good, so you rounded up then. And then this one?
0.423.
And are you rounding up or down? Rounding up as well? Oh, they disagree with you. What is it? 8, 6, 1, like this? Minus. What did you press that gave you the wrong answer?
I forgot to put the limit.
Aha! You just typed in 3 minus root 3 over 3. Yes, okay. This would be, so just so you know, just if I scroll up for a second, what's most common in the exam is actually starting from this line. They would give you this equation. But sometimes they make you do a little bit extra, like I said, and they give you the 2 equations here, and they ask you where do they meet. Okay? But that's only, I'd say, 10% of the time. 90% of the time, you're actually starting from this line. They would say something like, solve this.
So do we need to find the y?
Oh yes, very good. I forgot what I was doing, didn't I? I only found the x values, and I need to find the y values. So you can sub it back into 1 plus 3 e power x. So, what did I say? 1 plus 3 e power x. So if you sub those 2 answers in, we can get the y value. Thank you. Yeah, so I would have lost a mark there if I was doing this question, if I didn't pick it up later. Don't worry, I usually have time left at the exam to, at the end, to reread my work. I did a computer diploma last year in Griffith College here. It was a 2-year program, and one of the subjects was a maths class I had to take. So in the final maths exam, it was a 3-hour exam, but I was finished after 20 minutes. But I waited around for a little bit because I didn't want to make my classmates feel bad.
So,
You need to be proud of yourself.
Yes, well, you know, 100%.
so do we need to substitute the decimal point or ln?
If in the exam, what they usually like is you to put in more decimal places here, like 4 significant figures, and sub it in. If you wanted to be super accurate, you could put in this whole expression here, which I think is a good thing to do if it's not too difficult for you to type. Yeah? Did you sub it in? What did you get? What's the first one, sorry?
Negative 1.3558.
So 36. Yeah. 2.27.
So
Yes.
I got 5.732.
For which one?
First one.
Uh-oh.
I substitute the ln.
That's a big difference.
Yes.
It's 4 plus root 3 is the exact answer, which is, seems like that would be about 5 point something.
5.7.
Yeah, okay. And if you sub in this one here, that would be 4 minus root 3, which seems like it'd be, yeah, that seems believable. Okay. So if you want to give the exact answer, the first one was log 3 plus root 3 over 3, comma, 4 plus root 3, or log 3 minus root 3 over 3, comma, 4 minus root 3. That's the exact answer.
So but how do you get 4 plus root 3?
Ah, brain power.
Oh, okay.
I'll show you now. So if you sub this in directly, like that, who knows what happens here? These cancel.
Oh.
Yeah. E log A equals A, or log EA equals A. Log and E cancel. You can test it out on the calculator, you know. If you type in E log 7, you get 7. So then what this becomes is 1 plus 3 times 3 plus root 3 over 3, but then I see that those cancel, so 1 plus 3 is 4 plus the root 3.
Can you please scroll up a bit?
Yeah.
Teacher, the exam really asks is not really like this hard.
No, I think this could be an exam question, but usually they don't ask for the exact answer, so you can give a decimal answer. That would be the normal thing.
But there's a big difference.
In what?
And decimal answers is exact answer.
Difference
I mean,
how?
It's easier for the to get the exact answer.
Yeah, me too. Then I'm not
Unless
using a
it is-
calculator. Huh? What's wrong with this? That's great. What's wrong with it?
I don't know, I'm
Amazing.
just saying myself.
Stunned.
As a beauty. Yeah, so
Okay, write this one down carefully, please. It's really not as bad as it looks, because if you were to start at this step, right, the first thing you do is the minus b formula. Is that easy or hard?
Easy.
Easy. And you get these two answers on the minus b formula, right? And then you press log, and you get two answers, and you put the two answers back in. So provided you can use your calculator, it is actually quite easy.
Okay.
Trust me. Once you're doing them, it won't seem so bad. Now, we'll try these for a few minutes. I think we could say 1A, 2A, 3A, 4A, and 5A. And Okay, you can get started on those for a few minutes.
How many minutes do we have for that?
How many questions I give you? 1, 2, 3, 4, 5. 6 minutes. You have the potential to get them finished in 6 minutes. 1 minute a question is not totally impossible.